Is MasterPeace a chelator? Clarifying chelation, ion exchange, and adsorption. The word chelation is used constantly in the detox and wellness world, often with confidence and very little precision. It is invoked to mean everything from binding toxins to pulling metals out of the body. And because of that, it has become both a selling point and a source of confusion. So it's fair to ask a direct question. Is MasterPeace a chelator? The answer is yes and no, depending entirely on how the word chelation is being defined. This article exists to make that distinction clear, without fear-mongering, marketing shortcuts, or scientific sleight of hand. The goal is not to diminish chelation as a medical tool, nor to overstate what MasterPeace does, but to explain the mechanisms accurately so readers understand what is happening rather than relying on vague terminology. What chelation means in the strict scientific sense. In chemistry and clinical medicine, chelation has a very specific meaning. Chelation occurs when a metal ion is bound by a molecule called a ligand that donates one or more pairs of electrons to that metal, forming a stable chemical complex. A ligand, put simply, is a molecule capable of donating electron pairs to a metal ion. Pharmaceutical chelators, such as EDTA and DMSA, work this way. Their chemistry allows them to strongly and reliably bind metals, like lead, mercury, or iron, which is why they are used in cases of acute or severe metal toxicity. EDTA, for example, is a well-characterized ligand chelator that forms coordination complexes with metal ions. Its medical use in chelation therapy is described extensively in the scientific literature. Because ligand-based chelators bind metals through chemistry rather than biological context, they are powerful but also indiscriminate. They do not distinguish between toxic metals and essential minerals, which is why their use requires medical supervision and careful monitoring. Why the word chelator is used more broadly. Outside of chemistry textbooks, the word chelator is often used more loosely to mean something that helps bind and remove metals from the body. In biological, nutritional, and detox contexts, this broader usage is common. It is not inherently wrong, but it collapses very different mechanisms into a single term, which is where confusion begins. MasterPeace falls into this broader functional category. It supports the reduction of metal burden in the body, but it does not do so through ligand-based electron donation. Understanding that difference is key to understanding both its safety profile and its intended use. How MasterPeace actually interacts with metals. MasterPeace is a colloidal system that includes nano and sub-nano-sized, highly negatively charged zeolite, accompanied by sea plasma minerals. While sea plasma supports ionic balance and redox stability, it does not act as a ligand chelator and does not change the fundamental mechanism of metal binding in MasterPeace. Zeolite itself is a crystalline aluminosilicate mineral known for its permanent negative charge and ion exchange capacity. Zeolite does not chelate metals by donating electrons. Instead, it binds metals through electrostatic attraction and ion exchange. Electrostatic forces are attractions or repulsions between objects with electrical charge. Opposite charges attract, like charges repel. The zeolite lattice carries a permanent negative charge, while many metal ions carry a positive charge. This charge difference allows metals to be held or exchanged within the zeolite structure without forming a chelation complex. Because an outcome with zeolite, reduced metal burden, can resemble chelation, zeolite is often described as having chelation-like activity. Mechanistically, however, it is doing something very different. Extensive research describes zeolite's selective ion exchange behavior based on charge density and ionic size rather than indiscriminate chemical binding. Chelation, adsorption, and why the distinction matters. Another source of confusion is the tendency to lump all forms of binding together. Absorption, adsorption, and chelation are not interchangeable terms. Absorption occurs when a substance is taken into another substance, becoming part of it, like water soaking into a sponge. Zeolite does not absorb toxins. Adsorption occurs when substances adhere to a surface. That surface can be external or internal, flat or complex. Zeolite is adsorbent because its cage-like lattice creates enormous internal surface area within its channels and cavities, allowing substances to adhere without dissolving. A key contributor to adsorption is van der Waals forces, weak, short-range attractions between molecules caused by temporary differences in electrical charge. These forces are not chemical bonds, but they help substances adhere to surfaces. Along with electrostatic attraction and physical fit, they allow zeolite to temporarily sequester certain compounds. A useful mental model is this. Chelation behaves like a claw. Zeolite metal binding behaves like a charged cage. And adsorption behaves like Velcro. Plastics, PFAs, and what MasterPeace does and does not do. Plastics and PFAs are not metals, and therefore they cannot be chelated. Any claim that a substance chelates plastics is scientifically incorrect. That does not mean non-metal toxicants cannot be reduced. PFAS molecules contain polar regions, areas where electrical charge is unevenly distributed, which allow them to interact with charged or high-energy surfaces. MasterPeace's negatively charged nanostructures can interact with these polar regions through surface attraction rather than chelation. Environmental chemistry research shows that PFAS are commonly removed from systems through adsorption-based mechanisms, not coordination chemistry. Clinical data showing reductions of PFAS and microplastics via testing lymphocytes suggests that adsorption sequesters these compounds outside of cells, reducing their ability to interact with tissues and supporting the body's natural clearance pathways. Chelation, adsorption, and clearance are often confused because they can produce similar outcomes, but they are governed by entirely different physical principles. Particle size, cell membranes, and an important boundary. Healthy cell membranes carry a net negative charge due to their phospholipid composition and healthy internal integrity. MasterPeace particles are also negatively charged. Because like charges repel, MasterPeace does not enter healthy cells. MasterPeace doesn't have to do that to accomplish its cleansing support. This behavior aligns with well-established research on nanoparticle cell interactions, where surface charge strongly influences whether particles associate with or excluded from cell membranes. Rather than forced intracellular extraction, MasterPeace supports cells in a biologically compatible, charge relationship-based way. Observed changes inside cells, therefore, reflect secondary biological effects: altered exposure, reduced rebinding, and lymphatic signaling. Why zeolite's mechanism is safer for long-term use. Ligand-based chelators, such as EDTA, bind metals indiscriminately and strongly, which makes them valuable in acute settings, but inappropriate for casual or long-term use. Zeolite, by contrast, binds through selective ion exchange governed by charge, ionic size, and structural fit. Its action is self-limiting rather than forceful, especially when used in a mineral-supported context. Ion exchange has no intent. It responds to availability, and that's exactly why formulation and mineral context matter. This difference does not make zeolite weaker, it makes it more appropriate for chronic exposure scenarios. A brief clarification may help. Ligand-based chelators such as EDTA form soluble metal chelator complexes. These complexes remain intact, but because they are water-soluble and able to move freely within body fluids, they can circulate through blood and interstitial fluid before excretion. This movement, not release of free metals, is what is meant by systemic mobilization. Zeolite behaves differently. It does not dissolve, does not form mobile molecular complexes, and does not chemically transform what it binds. Instead, metals are held at a solid surface through electrostatic attraction and ion exchange. This immobilization prevents redistribution and is one reason zeolite's action is generally gentler and more self-limiting than true chelation. So, is MasterPeace a chelator? Chemically speaking, no. MasterPeace is not a ligand chelator. Functionally, it supports metal reduction. Mechanistically, it works through ion exchange, adsorption, and electrostatic interaction. Biologically, it supports detoxification without forcing extraction or overwhelming the body's regulatory systems. A clear and accurate way to state this is this. MasterPeace reduces metal burden through ion exchange and supports the reduction of non-metal toxicants through adsorption and improved biological clearance, not pharmaceutical chelation. Understanding how something works does not weaken it. It allows it to stand in its own strength. And in a space crowded with misinformation, clarity is not a liability, it's an advantage. To learn more about MasterPeace, see masterpeace.health.